C1 Quadratics Example 25. In this example, we need to calculate the value of the discriminant and then determine the number of real roots of each of these equations. So if you remember the discriminant, we can work that out by doing b squared minus 4ac. And then we can work out the number of roots by using these three properties here. So if we look at part A, we've got x squared plus 4x minus 5. So if I write down what I've got as my A, B, and C, so A is equal to 1, B is equal to 4, and C is equal to minus 5. So if I substitute these values into b squared minus 4ac, so I've got b squared, so I've got 4 squared is 16, minus, and then 4ac, so I've got 4 times a, so times 1, times c, so times minus 5. So this is going to be 16 minus, I've got 4 times 1 times minus 5, so minus 20. 2 minuses will give me a plus, so we'll get 16 plus 20, so that's 36. So that is the value for the discriminant. So if I look at this, 36 is greater than 0. And if I look at these three properties, if b squared minus 4ac is greater than 0, that means we have two real roots. Therefore, we've got two real roots in this case. So if we look at part B, I've got a equal to 1, b equal to 4, and c equal to 5. So if I substitute these values into b squared minus 4ac, I get b squared is 16 minus 4 times a times c. So I get 16 minus 4 times 1 times 5 minus 20, which is equal to minus 4, and this is less than 0. So if it's less than 0, that means we have no real roots. Therefore, in this case, we have no real roots. Look at the last one, part C. I've got a equal to 1, b equal to 4, and c equal to 4. So if I substitute these values into b squared minus 4ac, I've got b squared is 16 minus 4 times a, and then times c. So I get 16 minus 16, which is equal to 0. So in this case, I get one repeated root. Therefore, I have one repeated root.